Hi, sir.
Hi, Amy. How are you doing?
I'm good, thank you. How are you?
Good, good. So, how is calculus going for you?
Yeah, all right. Not bad.
Not bad. That's very good.
Yeah.
So, Amy, as you understand, we have actually covered most parts of the calculus. You know how to find the limits. You know how to find the derivatives. You also know how to apply different rules like power rule, product rule, quotient rule, and the chain rule, right? So, with these rules, and you understand the concept of first derivative, you also understand the concept of second derivative. Correct? First derivative gives you rate of change, tells you whether a function is increasing or decreasing. And the second derivative tells you about concavity, the point of inflection, and so on. Correct?
hmm
So many things are not known to us, and I think it's time to look into the type of questions which could be asked in the examination. That's the whole idea of studying all this, right?
Yeah.
Today's lesson is going to be very interesting since I'm going to pull out some questions from uh, from past and some questions which were seem to be very simple, but soon we will see how they get complicated when it comes to an examination, right?
Mm.
So the idea of today's class is to prepare you for attempting a test paper easily and getting good marks. That's the whole idea. So the format will be that I'll share with you some questions, right? And I'll give you time to work on those questions so that you could work. And then after a break of about, let's say, half an hour, we can again discuss the solutions, right? So like
Okay.
what we will do is we'll have a couple of quiz and test so that I'll call this as a mid-chapter review kind of a thing for us. So from each individual chapters, whichever I think are very important, from test point of view, I'll take up a few portions and then throw you 4 or 5 questions towards you. You need to solve, come out with your solutions, and then we'll sit down and discuss about the solutions you come up with. Does it sound good for you?
Sounds great.
Interesting, right?
Yeah.
Okay, so let me share the screen and let me share with you first set of questions today, which I picked from. Okay, so I'm calling this as extended exam review. Can you see these 4 questions on my screen?
Yep.
Perfect. Amy, think as if this is your test questions and we have taken derivatives as our first uh, part of the test. I like you to read the question as if this is your test paper, okay? And
Okay.
then share with me your thinking about how are you going to solve these questions, right? So can
Right.
you begin with the very first one?
The graph of the function y equals ax squared plus bx plus c passed through the point 4 minus 5 and has a turning point at 2 minus 9.
Mhm.
Apply the techniques learned in calculus to find the function.
Perfect.
Question 2. The graph of the function p of x equals x cubed minus x squared minus 8x plus 12 has x-intercepts and at, at a
And,
and b
and B.
and a local maximum at c. Find the coordinates of these points using calculus.
Correct.
Question 3. The graph of the function y equals ax plus b over x squared has a horizontal tangent at the point p minus 1 minus 12. Determine the nature of critical point at p.
Perfect.
And question 4. The graph of f of x equals 4x plus b and g of x equals x cubed minus 2x squared plus kx plus 12 is shown. The line f of x is tangent to the g of x at point 3, p, and it also intersects the graph at point q. Find the coordinates of point q.
Okay. So when you read these questions, what do you feel about them and like what goes into your mind?
Well, so when I see immediately when I see like equations and things,
Mm.
I if there are values given like in question 2, I try and picture some sort of graph,
Mhm.
roughly, and I look at like key points. So I'll just highlight like the intercepts, the turning points, and then when it says turning points and things, we know the derivative would equal 0.
Perfect.
So I'm just getting a few like points in my head.
Right, right, right. So as far
Yeah.
as the difficulty level goes, what do you think is there any question which seems to be difficult for you, or are they very simple?
Not very simple, but like they require a lot of like obviously you have to do a lot of thought to it, but like everything that we've done up to until now, I think obviously would all of that would help to do this. But they
Perfect.
don't look impossible, so that's good.
That's good. That's very good. So you're in good shape. You know your stuff. That's very good. Okay. So let me begin with the very first question, which seems to be a very simple question. Whenever it comes to a parabola, because ax squared plus bx plus c, and you're given 2 points and a turning point, that should not be very difficult. Parabolas you've been solving since ages, right?
Hmm.
Can you tell me the approach which you're going to follow to solve question number one?
So since that they've given us 2 points, can we
Mhm.
start by subbing in the values into
Yes,
the equation?
yes,
And then we'll get to equations.
yes. But you have three variables to find. How do you get the third equation?
Um, so it says it has a turning point at 2
Yeah,
minus 9.
yeah,
So we'll do the derivative, make that equal to 0, then sub the 2 in.
correct. So the key here is to understand that if you have to find three values, you should have three equations. So you have to look for those three equations, and clearly, as you said, 2 points directly give you two equations. The third
Mhm.
equation comes from the fact that the turning point is given to us, and this turning point happens to be at 2 minus 19. So here the derivative is going to be 0, which is 2ax plus b, and equating that we could actually get a third equation and find all the three unknowns a, b, and c. Perfect.
Mm.
Right. How about question number two?
Um, okay, so I did say that I'll just do a quick like kind of sketch in my head.
Yes.
So we know it's a cubic.
Yes. Leading coefficient
Um,
constant. Yeah.
yeah, so the right hand side will be up, there'll be opposite ends.
Correct.
Um, so we're looking for x-intercepts, so we have to find A and B, and a local max at C.
Yes.
Okay, so can we start by finding,
So make a rough sketch and then we'll discuss. So make a rough sketch on your paper and then we can discuss.
well, okay,
Yeah. For this cubic equation.
okay, I got a max and a min,
Okay. So how many turning points how many x-intercepts do you have in your graph?
3. Oh
Three.
no, yeah,
Three.
yeah, 3.
Okay, so
Is that
you
wrong?
begin with three x-intercepts. The question says, has x-intercepts at A and B? Do you see that? And a local maximum at C. That clearly means that there are only two x-intercepts. Do you get the idea?
Oh,
Right? So
yeah.
it's, the question makes things simple for you. It says that at A and B, right? So that means there are two x-intercepts and not three, right? Well,
Oh,
if you continue with this question, you will figure out that there are actually two x-intercepts. So beginning with three is not a bad idea. I mean, the way you're saying begin with three is just the correct thing to do, right? So even if you begin with three, you'll actually get the correct result because finally, when you work with the equation, you'll find that the two roots are exactly at the same point. And there we have a zero which has an order of two. So beginning with three is also correct. I should say is better, right? So you have the right approach right there. But if you get same roots, uh, don't think that your assumption was wrong. It is still a right assumption. The only thing is that the second x-intercepts overlaps with one of those which you thought of, correct?
all right.
So you have only two zeros, right?
Mm-hmm.
You have only two zeros. One zero may be linear, the other one is quadratic in nature. But otherwise, this question seems to be straightforward and it can be answered. Question number three. the graph of this function has a horizontal tangent at given point. Determine the nature of this critical point. How will you do this one?
Would you find the derivative?
Yes, first derivative. Perfect.
Yeah.
So you have to find the first derivative, and critical point means what for you?
Like critical number.
Yeah.
So
Number
x, so equal to 0.
derivative equals to 0 or not defined. Is that clear?
Yeah.
But it says horizontal tangent, that means it is a stationary point, and at this stationary point you have a horizontal tangent, right?
Yeah.
What is that P? And you can always find this out. And once you figure this out, you need to analyze your first derivative and then say whether it is a maximum or a minimum or neither, right? Because first
Yeah.
derivative, unless and until you do change in rising over rising, decreasing, increasing, you cannot confirm whether it is a maximum, minimum, or what, right?
Yeah.
How about question number 4? Can you read it again, please?
The graph of f of x equals 4x plus b, and g of x equals x cubed minus 2x squared plus kx plus 12 is shown. The line f of x is tangent to g of x at point 3p, and it also intersects the graph at point q.
Okay.
Find the coordinates of point q.
Okay, so the graph should have been shown here. Let me see if I can show you the graph. Okay, so this is actually the part of solution also, but here we have the graph right there, right? Do you see the graph? So right at the bottom of your screen, we have a graph in green and the line going through it, correct? So that's the graph you're looking at, where points P and Q are shown. The line is tangent, and so let me say that this line is tangent at this particular point, right? And then that is another x-intercept. So the graph of this function, 4x plus b and gx equals to x cubed minus 2x plus kx plus 12 is shown. Line f of x is tangent to g of x at p as shown here, and it also intersects at q. You have to find the value of b, which is part of the line, and k, which is part of your cubic function, correct? And then
Yeah.
point q. So what is going to be your approach in this particular case?
So I think I would start by finding the coordinate 3p, p,
Okay.
because when you find that, then you can find f of x, which is the line.
Yes.
So yeah, and then once you find that, because the cubic function intersects at that point q with the linear function,
Yeah.
to find q, you just have to make those two equations equal each other.
Perfect. I think that's a good approach. So what I will do at this stage is that you know how to solve these questions. So we can take a short break of about 30 minutes, go through these questions, provide their solutions, and then we can discuss solutions. Okay? Does that sound good?
Yeah.
Perfect. So all the best, try them out, and then let's be back again with the solutions and we'll discuss the solution.
Okay.
Okay. Hi, Amy. How are you doing?
I'm good, sir. How are you?
Good, good. So could you find solution of the 4 questions which we had been discussing?
Yeah. I don't know if they're right though, but I tried.
Okay, great. So let's discuss these solutions. Was there difficulty with any? Hi, Amy. How are you doing?
I'm good, sir. How are you?
Good, good. So could you find solution of the 4 questions which we had been discussing?
Yeah. I don't know if they're right though, but I tried.
Okay, great. So let's discuss these solutions. Was there difficulty with any one of them?
Not really, no.
Great, great. Okay, so I also did some solutions. We'll discuss the solutions and then you can let me know how it goes, right? So
Okay.
here is the very first question which I have solved. And what answer did you get
Um,
for the function? What is the value of a and b?
So for A, I got 1,
Okay,
B is -4, and C is -5.
that's perfectly correct. So you got exactly the same values which we were expecting. Perfect. So here is how we will like to do it actually. Let me share the solution with you. As you said, we have the equation and we are given that it goes through 2 points, which are 4 minus 5 and 2 minus 9. When you substitute these points in the equation, you actually get two different equations, right? So we're calling them as equation 1. And second time, when you substitute 2 minus 9, you get your equation 2. So from these two equations, we can eliminate C and we get one equation in terms of A and B. Correct? Now, to solve, we need three variables, so three equations. How do we get the third equation? As you said, we have to find the derivative, and the derivative of this function is 2ax plus b. So that gives you another equation with a and b. We know that there is a turning point at 2 minus 9. So if I substitute the value of 2 here, then the derivative is going to be 0. And therefore, we get our third equation, which is 4a plus b equals to 0. We can use these equations, 1, 2, and 4, to find the values of a, b, and c, correct?
Mm-hmm.
That's how you'll do it. I just sketched the graph here to give you an idea how this is going to look like. So that is how it is going to be. Okay, perfect.
Mm-hmm.
Let's take the solution for the second question now. What was your answer for the second question? We need to find the coordinates of these points, x-intercepts and the local maximum. Yes.
So I got, I don't know if it matters which one's A and B, but I just did
Yeah.
x-intercept 1 at -3, 0,
Okay.
1 at 2, 0, and a maximum at -4/3, comma 500/27.
That's perfectly fine. That's very good. Okay. Have a look at this solution. Does it matches with yours? And did you follow the similar approach?
Yeah, it's just when I was trying to figure out in the beginning, like which value would equal 0, it was a bit of trial and error. How do you do that without
trial and error? Oh, okay. So I'm saying x minus 2 is a factor, correct?
Yeah, I got to that, but it took me a while.
Actually, that is such a good thing what you shared with me. It does take time, right? Now let's review the polynomials. So when you are looking at a polynomial function, which is cubic in this case, then we have to look for possible values, correct? So the possible values are factors of the constant term, which is 12, divided by the factors of leading coefficient, which is 1 in this case. So you have to try many values, which include values like plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. Since all of them are factors of 12, right?
Wow.
So you plug in, like for example, you decide to plug in positive values, right? So you plug in 1, so you find what P1 is. Then you plug in 2 and find what P2 is. You plug in.
That's what I did.
Yeah. So whatever gives you a 0 is your first 0.
Yeah. All
At
right.
times it might take quite some time, as you're sharing with me. That is so natural. Is that clear?
Yeah, but what I didn't know was that it had to be factors of 12. I was just trying like randomly points.
Good.
Oh.
Factors of 12.
So it has to be factors.
Yes.
Oh,
so you try all those values. And another suggestion at this stage is when you find what P1 is, then make a note, whether it is negative or positive, right? Then you go for, let's say, P3, right? Was all the sign changed? That means in between I should have a 0. Polynomial is a continuous function. So you should not try all the values, alternate values. Because if it changes, I mean, the possibility is the center value which you missed was the correct answer. Correct?
That makes sense. Yeah.
To try 6 values, you have to make a judgment which ones to try first. Some of very easy to try. Like 1 and 2 is such an easy number to try. Never miss it, right? Plus
Okay.
minus 1, plus 2, minus 2 should always be tried. Easy calculations. So actually, I also tried two values, 1 and 2, and I got 2 as my right answer. Perfect.
Hmm.
Okay, so Emmy, it's a good time. Can you explain me the whole solution for our students?
Right. So once I found that x minus 2 was a factor, I divided x cubed minus x squared minus 8x plus 12 by x minus 2
Yes.
using synthetic division. Is that what you did?
Yes.
Yeah. So that's where, if you don't know that, just watch some of Mr. Kumar's videos. You just bring down the first one, multiply the sides, and put that there, and then add them.
Yeah.
1 times again, put the function there, add them, minus 6, and then times that minus 12. And because it's a factor, the remainder would obviously be 0.
Correct.
So then what you find out is it is x minus 2, x minus 2, x plus 3. When you multiply them out, they give you what we were intended, which is x cubed minus x squared minus 8x plus 12. So what we know is the x-intercepts are at x equals minus 3 and x equals 2.
Correct.
They're repeated factors. No, repeated, not factors. Are they? Yeah, repeated factors?
Yeah.
Yeah.
Zeros,
So that,
multiple zeros.
yeah. So because there are 2 of them, we know the order for at x equals to 2, it's going to be a quadratic.
Yes.
And at x equals minus 3, it's going to be like a linear line. I'm just talking about the sketching at this point.
Perfect. Yeah, that's a good thing. Sometimes this question can be extended and you may be required to sketch the function. And those are very critical points to note when you want to sketch this particular function, which could be definitely a part of your question in the test paper. Yes.
Yeah, I just find it handy, like looking
Yes.
at visually. So yeah. So then once you find the x-intercept, I made a quick sketch. So I just put minus 3, 0 as 1 point and 2, 0 as another point with the quadratic and a line.
Yeah.
And like I said before, with the degree, we know it's 3, so it will be opposite ends. And because it's the leading coefficient is 1, which is above 0, the right-hand side will be up.
Yes.
So just get a rough thing. Now we need to, I found the derivative of p. Is that what you do?
Yes.
Yeah, so I got 3x squared minus 2x minus 8.
Yes.
And I basically factored it out by multiplying the 3 by the minus 8. And I got x squared minus 2x minus 24. Then 2 factors that work with that is x minus 6 and x plus 4. Then I divided those 2 values by 3, and I got x minus 2 and 3x plus 4.
Perfect.
As the 2 factors. Yep. Then once I found that, what did I do? Oh yeah, so now we've got the derivative, we got that equaling to 0. Now we can find the critical numbers.
Yes.
Or stationary points, as you can say.
Yeah, same thing. Yes.
Yeah.
So
So we got
between critical numbers and stationary points.
So critical number is where f of x equals to 0 or does not exist, but stationary point is just equal to 0 in this case. So stationary point is the right word.
No, you critical number also. That's
right.
Yes.
So then I got the 2 points, and I did my little number line, interval table thing. Yeah. So I plot the point minus 4 over 3 and 2. Then I chose my test points. So I chose minus 2 for the far left, 1 and 3.
Okay.
It can be anything, yeah.
Yes.
They're only test points, so yeah. Then I subbed those values into the x bracket x minus 2 and 3x plus 4.
Correct.
And I got it as positive, negative, positive.
Yes.
So what that tells us is, because we're dealing with first derivative, it's going to be about the local maximum or minimum.
Yes.
So obviously, when it goes from positive to negative, you got your maximum, and from decreasing to increasing, you got your minimum.
Correct.
So that shows we got a maximum at minus 4, 3.
Yes, we are interested in maximum, right? C.
Yeah.
Correct.
So once we find, obviously, that it's at minus 4, 3, we need to find a y value. So I took that minus 4, 3 and subbed it into the p of x.
Yes.
Yeah. And I just used the calculator, and I got 500 over 27.
Good job. Good job.
Can you leave it like that, or
Yes.
decimal is better?
Sometimes in your test papers, they'll say 3 significant figures sometimes.
Oh, okay.
And you have to read the question paper very carefully, because at times right on the top, they will write all the answers provide exact value or round them to 3 significant figures if not mentioned.
All right.
If not mentioned. So you have to read it very carefully. Accordingly, you answer, right? So 500 over 27 is a safe bet because it is exact value. You get
All
it?
right.
So
Yeah.
it works for both the cases, so that is better.
Wait,
Okay.
so sorry, just quick thing. If you're
Yeah.
saying that if it doesn't specify exact value,
Yeah.
you assume that it's 3SF.
No, you have to read your test.
Oh,
If the test paper says so,
yeah.
then only.
Oh, okay.
So
Okay.
yeah, it is kind of critical. Now, you have 2 parts in the test paper. One is with calculator, one is without calculator. Perfect. So if it is without calculator, exact value 500 over 27 is done, right? But if it is with calculator, as this question might be with calculator, you have to read. If it says 3 significant figures, you have to write 18.5.
Okay. Makes sense, yeah.
Yeah. These things are very critical. They may just cost you 0.5 marks unnecessary.
Yeah, I've lost marks just literally with rounding or like 3SF. It's so annoying.
Let's see question number 3 now. Okay. What is your answer? Can you just read the question quickly and tell me what we were trying to figure out and what answer did you get?
Yeah. So the graph of the function y equals ax plus b over x squared has a horizontal tangent at the point -1, -12. Determine the nature of the critical point at P.
Correct. What did you get the answer?
So I got the maximum.
That's
So
it.
is this so is that what the critical point is? Because I just got maximum at x equals 1.
So
-1, sorry.
critical point, your derivative is horizontal or it is undefined, right? It could be 0 or undefined. So in this particular case, when you analyze, that happens to be maximum, local maximum, I should say, because at this point, when you check the first derivative, it changes from increasing to decreasing. So I just provided the graph for our students' benefit that this is how it actually looks. Now, whenever you're working with functions, you'll find this particular function ax plus b over x squared is a very common question in test paper, and that function you will see in many different forms. It could be sketching a rational function, right? And you may have to sketch this, and therefore it's important to look at the graph also. So when you are answering an example, right, in your textbook, try to see that example from different angles. Like that could be part of curve sketching. You understand?
Yeah.
So ultimately, you're looking at the final graph. So even if it is not asked for, they're just saying, find the nature of critical. It seems to be like half done. The ultimate question could be like, just sketch the graph.
Sketch. Yeah.
So
Okay.
you have to move forward, and because you're practicing, that is how to see it. Correct?
That's true. Yeah.
So once again, Amy, I'll request you to go through the solution for the benefit of our students.
Right. So I started with the point. So it says horizontal tangent point at -1, -12. So because that's going to be a point on the curve,
Yeah.
I found the derivative,
Mm-hmm.
and then I subbed the -1 in. So to find the derivative, I put it into exponential form.
Okay.
Just to quickly help me.
X to the power minus 3. That's correct.
And then so I got bx to the -2, so -2 bx to the -3, which is -2b over x cubed.
Correct.
And then when I subbed in x equals -1 into that, I got a plus 2b equals 0.
Correct.
Yeah. And then what I did was I took the value, the point on the curve, and I subbed it into the equation.
Yeah, that's good.
Because I needed another equation, because like you said, when there's two unknowns, there should be two equations.
Correct.
Yeah.
Correct.
So I got -12 equals -a plus b.
Perfect.
So if we rewrite that into a nicer form, it's a minus b equals 12.
Yes.
Then I made those two, I did simultaneous equations and cancelled the a's, got -3b equals 12. So we got b as -4.
Okay, that's correct.
And then I subbed in the b -4 into just one of the equations. So I chose a minus 4 equals 12. So a equals 12 minus 4, which is a equals 8.
Correct.
So now we've got our two values. I just rewrote the equation as y equals 8x minus 4 of x squared.
Perfect.
Then I found the derivative of that.
Yes.
So 8x derivative would just be 8. And again, with the -4x squared, I know you said I have to just do it immediately, but like I'm still getting used to it. So I did the exponent form and got +8 over x cubed.
Yes.
And then I made the denominator both x cubed. So I got 8x cubed plus 8 over x cubed. And 8 is common, so I took it out of the bracket and did 8 bracket x cubed plus 1 bracket over x cubed. So critical number, so this is the point where you said many people kind of go wrong, because the critical number is where f of x equals 0 and does not exist.
Yes.
So 1 point obviously would be -1, because inside the numerator bracket would equal 0, but also the denominator can equal 0 for it to not exist.
Yes.
So x equals 0 and x equals -1 are the 2 points.
Perfect. So you made a good note here that critical number is a point, is a point on the curve where the derivative could be 0 or undefined, right? Does not exist. So denominator is 0. That means y dash cannot be calculated, right? Does not exist. So x equals to 0 is a critical number, right? Numerator is 0, gives you a 0 for the first derivative, which is at -1. So now when you analyze with the interval table, you have to use both these values. Then you get the correct answer. Otherwise, you don't get the correct answer.
Yeah.
Correct?
That's the key point.
Imagine if you miss this point, then you get increasing and increasing. You get a wrong answer. You get the idea now?
Yeah.
So that is very, very critical, right? So can you quickly explain me how to use this interval table?
Yeah. So we've obviously got our 2 points, 0 and -1. I just plotted them on a little line, but you can use the table and choose test points. So a value from -infinity to -1. Choose a nice easy value like -2. A value between -1 and 0, -0.5, and a value between 0 and infinity, just choose 1, nice easy number. Then I subbed those test points into our
derivative.
So x cubed and then x cubed plus 1.
Yeah.
And I don't need to get so don't get exact, you don't need to write down the exact values, you just need to know whether it's negative or positive.
Perfect.
So I got positive, negative, positive.
Yes.
So what that shows is, because we're dealing with the first derivative, it's showing the local maximum or minimum. So because it's going from increasing to decreasing, we've got our maximum at x equals -1.
Correct.
And we got a minimum at x equals 0. But we don't need to know that.
Okay. Now, at 0, we have a discontinuity. So this will not count. You understand? This is not in your domain. We do have a minimum there, right? Minus infinity is going down. You see that?
Yeah.
However, this critical point is important for the analysis part. But remember, at this point, we have a restriction. X square is in the denominator. So the restriction for this particular rational function is that x is not equal to 0. So you cannot report that to be a local minimum, right?
Oh. So I
So
got that wrong. So you can't write that.
you cannot write that. So you
Oh,
have to
okay.
just make this table. It is good practice to write 0 with the filled in thing, like, let me just show you. 0 with the filled in and this with the whole. You understand? So that you know, ultimately in your answer, that should not be reported as a minimum or maximum, right? Because
That
that
makes
is not
sense.
a part of domain, right? And another good thing here is that, I mean, which you should do is you should write that x is not equal to 0.
Oh, yeah. So I remember you saying that. Always start with that.
Always start with kind of restrictions, right? And then move forward. So that's a good thing we have learned. Very good. And these are common mistakes, I mean, which you're sharing. And if students avoid that, they can actually max the paper.
Mm.
Now let's look into solution of the fourth question, which I think is very difficult to do. Can you please read the question once again, and then we'll discuss?
Yeah. Quite long,
It is.
but yeah, I liked it. Okay. So the graph of f of x equals 4x plus b, and g of x equals x cubed minus 2x squared plus kx plus 12 is shown. The line f of x is tangent to g of x at point 3p, and it also intersects the graph at point q.
Yes.
Find the value of b and k, and find the coordinates of point q.
Correct.
So yeah, so four unknowns,
Yes.
kind of, yeah, four unknowns. So what I did was I started by finding the derivative of g of x,
Okay.
because that's the curve, right?
Yes.
So I found the derivative, which is 3x squared minus 4x plus k.
That's correct.
And because we know there's a point on the curve, which is 3p, and we know what x is.
Yes.
So that was handy. So I just subbed 3 into the derivative, and I got 27 minus 12 plus k equals 4.
Perfect. How did you get 4?
Oh, wait, I said g of 3 has to, because 4 was the gradient.
Gradient of
And
the line. Correct.
yeah.
At that point, the gradient is same. And that's the thing, right? So it's given f of x is 4x plus b, and this 4 is the gradient, and g dash 3, g prime 3 is the gradient. And therefore, we'll equate this 4 to the equation, and we can find k. So that's a very tricky part. You got it right. That's great. Move forward, please.
So when I got that, I got k equals minus 11.
That's correct.
Right. So then I just subbed the k back into g of x and got g of x equals x cubed minus 2x squared minus 11x plus 12.
Mm-hmm.
Then, so now we found k, we can find point p
Correct.
by just simply subbing in the 3 into g of x,
Correct.
and I got p is minus 12.
That's correct.
So now we've got the point. That then helps us to find the equation of the line,
Yes.
f of x, by simply just subbing in the point 3 minus 12 into 4x plus b.
Yes.
So I've got minus 12 equals 12 plus b, so b equals minus 24.
That is correct.
Yeah, so now we've got our two equations, which is g of x, so I said the g of x one, and then the f of x equals 4x minus 24.
Correct.
So now, I wrote at the point Q, there is an intersection, which means both of those equations, g of x and f of x, are equal to each other. Yeah. So then you take the two equations and make them equal to each other. So I got x cubed minus 2x squared minus 15x plus 36 equals 0.
Yes.
And because we found the point 3 minus 12, it shows that x minus 3 is a factor of that equation.
That is correct. So this cubic equation, you don't have to do trial and error as you did in the previous question, right? Here, we have already given you one solution. So use that particular solution to divide the cubic equation by your factor and find the quadratic equation. Once you do that, again, follow the steps. You could do long division or synthetic division as shown here. Then you get your quadratic equation as x squared plus x minus 12, factored form x minus 3 times x plus 4. So you can write your function now in factored form, and there you go. You get all the three factors for the function g of x, correct?
Yeah.
Yes. So how do you find q now?
So obviously we got x equals minus 4 and x equals 3, but 3 we already is given, so it's not going to be the other one. So x equals minus 4, and we got that. So you just sub in, to find the y value, you just sub in minus 4 into g of x.
Yes.
And we just do minus 4 cubed, minus 2, but then minus 4 squared, and then minus 11 minus 4 times by minus 4 plus 12, and you get y equals minus 40.
Correct. You could have used the line equation because it is common.
Oh, yeah. For that.
Yeah, so you could use f of x, right? F of x equals to 4x plus b, right? Substitute minus 4 there. So 4 times minus 4 is minus 16. And you know the value of b, which is minus 24, right? And from there, you get minus 16 minus 24 as minus 40.
Yeah, that would have been the more time, not time wasting.
Yeah, that's critical in tests. You know, sometimes test papers are so, balanced that if you spend some extra time somewhere, it may cost at the end.
Yeah.
So anyway, that was good job done. Very brilliantly solved, Amy. That's great.
Thank
Here
you.
is an extension to this particular question. Can you read this extension, please?
Yes, so the y-intercept of g of x is r 0, 12.
Correct.
Find area of triangle PQR.
Now, let's try to understand this.
Okay.
That y-intercept is very clear, which is 12, right? Because when I substitute in g of x, x values will be 0, right? So all these three will be 0. The constant will be 12. So we get this value of r, which is 0, 12, correct? You can read that. Now, as you can see, we have a triangle here, right? Do you see this triangle?
Yeah.
Find the area of this triangle, and that could be a bonus question for you. How do you find area of a triangle which is not a right angle triangle?
Is that the...
This is not a right angle triangle. So these is a scalene triangle, 3 different points. How will you find area of this triangle? Can you suggest?
I was gonna say half AB sine C, but I don't think you used that.
You could do that. You could do that. How do you get the angle? Now explain me that. Yes. Half AB sine C is perfectly fine. How will you get the angle?
I don't honestly know.
Okay. You have to find angle between 2 lines, correct? So you know tan A plus B formula, slightly tricky for you since you have not done the trigonometry of compound angles. So that is slightly tricky. Second, you have also not done how to find angle between 2 lines, correct? Have you done?
No.
If you have done that, then you can use that particular formula because, QP is one line and QR is another line. So between these 2 lines, we can find the angle theta. So once you know this angle theta, you can use the formula half AB sine theta.
Oh, that would work. Yeah.
So make a note. You have to learn this method of finding angle between 2 lines.
Find angle between 2 lines.
Correct. Any other method which is known to you? Heron's formula, do you remember?
Oh, yeah, that was way back.
right?
I can't remember the formula.
Correct. So in Heron's formula, we calculate the value of S, which is semi-perimeter, right? So you do, let's say, now we're given three different points. You have to find distance between all the three lines of this triangle. Let's say distance is A, B, and C. Then S is A plus B plus C divided by 2, right? And then the formula goes like square root of S minus A whole square and all. So make a note, Heron's formula. So have a look at Heron's formula. That is another way of finding area of this particular triangle. Okay.
Okay.
However, the best way is the formula which I am sharing with you today. Make a note of this formula. If you know the three coordinate points, as we know in this particular case, you don't have to look to trigonometry or any other thing, right? Apply this formula and I'll tell you
Oh.
the concepts later.
Have I seen this formula before or no?
Might have, if you've done coordinate geometry. You haven't done that with me, so I'm not sure about it.
Oh, I don't think I have. Wait, so this works
It
every
works.
time?
Correct. And it's not very difficult to remember the values. As you can see, x1 times area of triangle. Let me read the formula. Area of triangle is half of those two bars are absolute value. Area is always positive, right? So absolute value of everything in between, which is x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. The important thing here is that you have to go in an order, right? You have to go in an order. You go, like the order is 1, 2, and 3, correct?
Oh, yeah.
All the numbers are going in this cyclic order. If you change the order, you are going to get a wrong answer. So you see x 1, 2, 3 order being maintained, right? Then again 1, 2, 3, right? 2, 3, 1. Same thing, right? 2, 3, 1. And then 3, 1, 2. 3, 1, 2. Do you see that cyclic order?
Yeah.
So that helps you to correctly remember the formula and it can be applied. So,
Oh,
yes.
just got it. Yeah. All right. Okay.
Yeah. So now, can you read the formula for area of triangle? And let me know if you understand it clearly.
Right. So area of triangle, half of, so x1 bracket y2 minus y3
Yes.
bracket add x2 multiplied by y3 minus y1, add x3 bracket y1 minus y2.
Take absolute value of all this, right? Divide by
Yeah.
2, get the area of the triangle. So that is another very important thing to remember, right? And that's where I think we can end this particular session of learning how to solve application questions in examination. So what we saw here is normally when you study calculus, they will say given equation, given point, find derivative, right? That is how it is. Given equation, find local maximum minimum. Given equation, sketch the graph. That is what you learn. But when you sit in the examination hall, there'll be at least two questions where the equation is not really given to you. There are parameters like A, B, C, K, and so many things. They will give you the other things. For example, this local maximum is this, find the equation, correct? So the exercise which we focused on today was like this only. We are given so many other conditions, we have to find the equation.
All right.
Just
Yeah.
and if you look at it from this particular point of view, I think you have nailed two questions from your test paper in calculus.
All right.
Perfect. So
Yes.
that's how it should be. So how do you find this exercise?
It was actually really helpful. Like, especially with these kind of questions, they're the ones obviously with the most marks because it's going backwards and changing the way you normally function with your brain. So yeah, that was really good. And like applying all the concepts that we know and like actually understanding why we're doing what we're doing.
Yes.
So that helped me, not just like the first derivative equals 0, local max. Like now I know when the local max is given, I
Yes.
immediately think find first derivative, make it equal to 0, and it just all works now. Like everything's making sense. So that's good. Yeah.
Perfect. And you also notice that in the last example, we had a lot of flexibility in providing a solution. So, especially the area of the triangle, right? Now, with GCSE, it really works because GCSE is a standard program which is being run in many countries. Now, in different countries, students are looking at the same question in a different way. So, the last example really shows that you could find area using half AB sine theta. You could find area using the Heron's formula. You could find area with the formula which I gave you, right?
Mm.
Using the
Yeah.
coordinate points themselves. So that is the shortest way of finding this particular area, and that should definitely give you an advantage over others when taking such a question. Okay?
All right.
So let's end this session here. And in our next session, we'll learn about strategies to solve uh, examples where we have to write the equation and then do the needful. Okay, so a word problem will be given, real life situation, and we'll have to write the equation and then adjust the variables, right? One variable in terms of the other, find the derivative and get the solution. Okay,
Okay.
so that is going to be our next lesson. So I hope that will give you good practice.
Yeah. Thank you so much, sir.
Thanks, Amy. Thanks a lot.
I
Okay,
really appreciate it.
thank you. My pleasure.
Bye, sir.
Bye.